I want to, I guess, bring up a couple of points about what happens if we're looking for something other than what we look for. If we have, before you look at the table, I'm just going to ask some questions and see if you can figure out the answers without looking at the table. If we have a two-tailed test instead of a one-tailed test, everything else is the same for the study. We want beta to be equal to what did I say it was?
0.1.
No, beta.
0.10.
Okay, beta be 0.10. We want power to be 0.9. So everything is the same. If we have a two-tailed test, do you think that we're going to have more subjects that are required or fewer subjects? More. Confirm that. Look up at the top part and tell me what the number should be. So instead of being 54, the number is 64. Okay, now again, don't look at the table. If we're going to have an alpha level of 0.05 instead of 0.01, what effect will that have on sample size? If we have an alpha of 0.05, what that does is increase our chances of a type 2 error. What impact will that have on the sample size? Will we need to have fewer subjects or more subjects? Fewer subjects, yeah. So everything is the same now, except it's going to be 0.05. We found that sample size before for 01 was 54. Now for two-tailed test, for 05, it's 36. Okay, one more thing. What happens if instead of looking for a difference of 10 points, we're going to look for a larger effect? Let's say the effect is going to be, instead of a half a standard deviation, it's going to be 1 standard deviation. Remember I said something about the fact that if we're looking for something bigger, it probably does not require as many subjects, right? So let's look at the same problem. So instead of having a d-value of 0.5, we have a d-value of 1. Let's see how dramatically that reduces the sample size. And everything else now is the same. Everything else is the same with the exception of the d-value. If we look now at this, and the d-value is 1, instead of having a sample size of 54, the sample size is 16. So see what happens by the different kind of decisions which are made? It has an effect on what the sample size will be. And so this is why if you go through these steps, you may come up with a different number than I will come up with. But what I came up with as far as the steps are really pretty reasonable as far as what those steps should be. Yes?
If you're back to the principal and the superintendent, money's a problem, so you would want to go for a smaller sample size, wouldn't you?
Sure. I'd like to have the smallest possible sample that I could have. But I also want to make a correct decision. If the mean IQ of the children is indeed less than 100, I'd like to be able to detect that difference, and I'd like to be able to provide the funds. I don't want to make a type 2 error, but I want to be fairly certain about the fact that if I reject the null hypothesis, that I'm going to make a correct decision.
Now, is that going to go down as your difference is?
Well, let's review that. So, okay, let's review the decisions in the last minute and 30 seconds here before we wrap things up today. There's concern about rejecting a null hypothesis, which is true. That is, saying that the children's IQ is less than 100 when in fact it's not. So to reduce the chances of making a type 1 error, we have a small alpha level. Okay? Then, we want to also reduce the risk that we have of making a type 2 error. So we said we want to have power be pretty high. We want to have power be 0.90. So we're putting that into the mix. Okay? Then we decide what is the difference that we're looking for, which is enough to be able to reject the null hypothesis. That's the D value. So we put all of that together, and then we come up with what the number is that we need in order to be able to conduct the study.
But if we were saying, as you were saying earlier, we only have enough funds to test X number of kids, then would you then try to adjust one of these numbers so that you felt like you got a decent test?
What can you adjust?
Well, if you were looking for a bigger difference, or if you changed the data, I mean.
That's what we'd have to sacrifice. We'd have to give up some of the power, because there's no way we're going to have that same power if we're going to have fewer subjects. If we only have, let's say, we can only test 25 kids, 25 students at the school. No way that power is going to be what we'd like it to be. Power, instead of being 0.9, is probably going to be somewhere around 0.6, 0.5. Then it's like, is it really worth it to do the study? Our risk is so high of committing a type 2 error, it's probably not worth it. Do you understand all these issues? You know, it's a fairly complicated situation. And I want you just to understand, though, that the number is an approximate number. One question before we go. What is it?
Still have that pencil to...
It's up in my office. I don't have it with me. See you on Thursday.